Hello and welcome to our very important discussion for today, and that is arachidonic acid metabolites, arachidonic acid metabolites, and their involvement in the inflammatory reaction. So, if we take a look, we will see an inverted diagram. Please be patient with me. This inverted diagram will show us the plasma membrane of these white blood cells, in which we will have phospholipids such as linoleic acid, and in which we will have inserted esterified arachidonic acid. This arachidonic acid serves as the source from which these metabolites will later be extracted through one of two pathways. This is very important to understand. It's very important to understand that we begin at the cell membrane, where these cellular membrane phospholipids will provide us with the building block for the generation and extraction of these inflammatory reaction metabolites. And these metabolites originate from arachidonic acid particularly. You need to know that. And this arachidonic acid will later undergo one of two pathways, either the cyclooxygenase pathway or the Lypooxygenase pathway. The objective of today's discussion is to understand how does arachidonic acid later on, after going through these two different pathways, give us different metabolites that participate in different ways and affect the inflammation process in their respective ways. You need to know that. You need to know where did arachidonic acid came from. You need to know what are the enzymes that bring it down from the cell membrane and prepare it to undergo these biochemical pathways. You need to know how many pathways are there involving the generation of metabolites from arachidonic acid. There are two pathways. The first pathway is the Lypooxygenase pathway, and the second pathway is the Cyclooxygenase pathway. So now let's examine in detail. Before we examine in detail what takes place, not in very excruciating detail, obviously the procedure can go in depth with all of these different molecules, but we will take a general look of mostly the important things we need to know in relation to what are these metabolites generated from arachidonic acid and what is their role in the inflammatory process. And we will not go in very deep detail. We will only go through what we need to know as physicians or potential physicians or medical school students or undergraduate students. So now, without any further ado, before we go through that, let's just quickly refresh. We talked about how inflammation arises as a terminal stage in our chain of chronological events that begins with a normal cell, a normal healthy cell that underwent a stressful or noxious insult. That stressful insult could be trauma, contusion, or maybe a bruise, or then we can have a physical change like very severely high temperatures or very freezingly low temperature, or maybe a chemical agent like a corrosive agent, or maybe an infection or infective agent such as bacteria, viruses, fungi, parasites, and so on. And the cell is equipped with built-in control systems that allow the cell to fight back against all of these different stressful stimuli and usually overcome. However, sometimes that stressful stimuli could be very long in duration and severe in intensity, leading to these cellular built-in systems of survival to be overwhelmed and damaged, and now we will have an injured cell. We will have cell injury. Cell injury will have to then propagate, and we will now have irreversible cell injury. And after irreversible cell injury, we will have cell death. And after cell death, we obviously will have cell death by necrosis, not apoptosis, because cell death through apoptosis will give us, we will go right back to being a normal cell. However, a necrotic cell death, where the cell membrane will be fragmented and intercellular content will be splashed and will be dispersed in connective tissue and nearby cells, leading to resident sentinel cells detecting that that cellular debris and detecting those microbes and infective agents, and then they will release mediators, inflammatory mediators, to recruit to recruit white blood cells circulating in our blood vessels, such as the monocytes, giving us the macrophages, and we also have polymorphonuclear cells such as the neutrophils. And then we will begin the inflammatory process, acute inflammation, where, as we said, sentinel resident cells will detect mechanically through their receptors lipopolysaccharides of infective agents on the surface of these infective agents, like these bacteria and viruses. They will actually be detected by these mast cells, dendritic cells, and macrophages, and we will also detect necrotic debris through these cells. They will send the signal to the white blood cells circulating in our blood, obviously inactive. And when these cytokines have been released by the resident cells, now these circulating white blood cells will begin to aggregate to the site and the source from which these cytokines, these chemokines, these interleukines will gravitate towards the site of the emergence of these cytokines. And we will also have the endothelial cells reacting to these cytokines, where endothelial cells will retract, and we will have interendothelial gaps. And as we talked in the past lectures, we talked about how these white blood cells will now be activated, and they will roll, and they will transmigrate through these interendothelial gaps, and will travel through the extracellular matrix using their proteolytic enzymes to degrade the extracellular matrix and connective tissue in order to arrive at the site of the inflammation and fully exit the blood circulation and enter the tissue where there's an inflammation, where they perform their function of engulfing and properly digesting, using these reactive oxidative species, nitric oxidative species, to destroy these infective agents or get rid of that intercellular debris, to pave the way, pave the path for healing. And hopefully we go back to being normal tissue again through resolution, or maybe the damage will be so severe we will undergo healing by fibrosis and scarring, or maybe if the damage is very severe, we will now move on to the next stage from acute inflammation into chronic inflammation. So now where are we exactly? We are at the stage of how these cytokines, how these mediators that are released by the macrophages and the mast cells and the dendritic cells, how are they synthesized intercellularly? So the first step, we have our, where is my laser pointer? Probably ran out of battery. Oh no. Okay, so this is the cell membrane of the dendritic cell or the mast cell or the macrophage, that are sentinel cells that are resident in the tissue, in all the tissues they are like police precincts. They are in the neighborhood, and when there is a damage, when there is an incident, they contact these very big powerful units. They come to the site of the problem and they rectify the situation. So we have in the membrane of these sentinel cells, dendritic cells, the mast cell, and the macrophages, we have phospholipids. And particularly we have a phospholipid called linoleic acid associated with this arachidonic acid in the esterified form. So when there is an inflammation and these sentinel cells, these resident white blood cells need to secrete cytokines and mediators, what happens is this is very important. Phospholipases are enzymes that degrade arachidonic acid from its structurally stable inactive form that is esterified in the plasma membrane into an active form that is now subjective to cyclooxygenases and Lypooxygenases enzymes, and then we can start to build and generate and produce these metabolites. So now phospholipases will convert to us an esterified, stable arachidonic acid to an active arachidonic acid molecule. That's why we use steroids as drugs that are anti-inflammatory drugs, and they inactivate the phospholipases that prepare for us the arachidonic acid that would later be used as a source to generate the metabolites that will become the mediators of the inflammation. So the first step, we convert arachidonic acid to an active form through the phospholipases. If we don't want that, we use we take drugs, anti-inflammatory drugs that are steroids, and you know where they perform their function. They perform their function right at the beginning. They block the phospholipases from exerting their function of giving us the arachidonic acid. Then we have one of two pathways. The cyclooxygenase pathway will give us one of three products, while the Lypooxygenase pathway will give us one of four products. Three products pro-inflammatory, while one product is anti-inflammatory. But let's talk about each product. Let's now take the first pathway, and that is the Lypooxygenase pathway, where the arachidonic acid will be metabolized and undergo a catalytic enzymatic reaction under the effects and the activity of the Lypooxygenase enzyme, and that will give us 1, 2, 3. One, we will have leukotrienes. We will have the production of leukotrienes. So now if you're asked on the exam, how are leukotrienes made? You say they are made through the effects of the enzyme Lypooxygenase on the substrate arachidonic acid. So that's the first product. We generate leukotrienes. And we also, this first reaction is very important for the chemotaxis, which is the movement of these leukocytes towards chemical gradient, where these are released. These chemokines, these chemokines released during inflammation, they bind receptors on the leukocyte that cause cytoskeletal rearrangement, where the actin and myosin filaments will push the cell to extend towards the site at which the chemokines bound the receptor, and that's how these leukocytes will migrate to the site of the inflammation. So now we have the 5-lipoxygenase acting on the arachidonic acid to give us the leukotriene activity, and we can use drugs to inhibit the entire pathway, and they are called Lypooxygenase inhibitors. The other product will be bronchospasm. So the metabolites that are generated by 5-lipoxygenase acting on the arachidonic acid will cause bronchospasm. And also we have another alternative drug, and that will be the receptor antagonist, leukotriene receptor antagonist, and that will prevent bronchospasm during the inflammation. So these two events are pro-inflammatory. Leukotriene generation and chemotaxis toward the site of the chemokine release in the inflammation, the bronchospasm, and the third option will be increased vascular permeability and opening of these interendothelial gaps through which white blood cells will escape the blood circulation and migrate to the site of the inflammation. These three steps are pro-inflammatory events, pro-inflammatory products that are generated by Lypooxygenase acting on the arachidonic acid. However, there is one additional step that I put as number 4 here, and this does not involve 5 Lypooxygenase. In fact, it involves 12 Lypooxygenase. And 12 Lypooxygenase generates for us lipoxins, such as lipoxin A and lipoxin B, and that leads to the inhibition of inflammation. So the lipoxygenase pathway is not entirely pro-inflammatory. The 5 lipoxygenase is, you can be asked on the exam, is 5 lipoxygenase pro-inflammatory or anti-inflammatory? Yes, it's pro-inflammatory. Is 12 lipoxygenase pro-inflammatory or anti-inflammatory? It is anti-inflammatory. 12 lipoxygenase acting on arachidonic acid will lead to the production of lipoxins, and lipoxins will inhibit inflammation. That's very important to understand. Now let's look at the second pathway, and that is the cyclooxygenase pathway. So just like lipoxygenase can act on the arachidonic acids, we have cyclooxygenases that are also capable of acting on the arachidonic acid to give us metabolic or to give us pro-inflammatory products. And with the cyclooxygenases, there are no anti-inflammatory effects such as we have seen here with the lipoxygenase. In the lipoxygenase, we have five lipoxygenase giving us chemotaxis and bronchospasm and increased vascular permeability, while 12 lipoxygenase giving us lipoxins that lead to the total inhibition of inflammation. However, cyclooxygenase, there is no whatsoever any products that are anti-inflammation. In fact, all of the effects of the cyclooxygenases are pro-inflammatory. And before we talk about the drugs that inhibit cyclooxygenases, let's talk about the products. The products of the cyclooxygenases are prostaglandins. That's how we get prostaglandins. If you're asked on your exam, which of the 2 pathways that arachidonic acid undergoes to give us metabolites, which of the 2 pathways leads to the production of the prostaglandins, you know it's cyclooxygenase. The second thing you need to know, not all prostaglandins are pro-inflammatory. Some prostaglandins are anti-inflammatory. Some prostaglandins are anti-inflammatory. So we will see. We have cyclooxygenases giving us, participating in the prostaglandin synthesis, and we will have prostacyclin, the first product generated by cyclooxygenase enzyme acting on the arachidonic acids pathway is the prostacyclin, and we have PG. You need to know those PGI2. PGI2 will cause vasodilation and inhibition of platelet aggregation. You need to know that. So the first product of the cyclooxygenase pathway is the prostacyclin production. What does prostacyclin do? It generates this PGI2, which inhibits platelet aggregation. You see platelets here are separated, they are not aggregated, and leads to vasodilation. You see these orange arrows pointing out, meaning that there's a dilation. And that is a pro-inflammatory event. You know, in inflammation we need vasodilation, and we need increased permeability, and we need decreased platelet aggregation. Another event that is another event or another the second product of the cyclooxygenase pathway is the thromboxane A2, TXA2. And TXA2 causes vasoconstriction and platelet aggregation. You see the orange arrows are pointing inward here. So that shows you that thromboxane acts in the opposite fashion against prostacyclin. So these two, they are like in a tug of war. So if you have less prostacyclin, that means you will have vasoconstriction and platelet aggregation. And if you have less thromboxane, that means you will have more vasodilation and you will have more inhibition of platelet aggregation. So that's the second product of the cyclooxygenase pathway, the thromboxane A2. What does thromboxane A2? It causes the opposite of prostacyclin. You need to know that. You need to know that prostacyclin causes vasodilation and inhibition of platelet aggregation. You see how separated these platelets are, and we will have vasodilation. So this is a pro-inflammatory event. While in thromboxane A2 generation, we will have vasoconstriction, so the blood vessels are tighter, and we'll have platelet aggregation. The third outcome of the cyclooxygenase pathway will be the PGE2 and PGD2. The numbers refer to the double bonds, and that causes vasodilation and increased permeability. You see the arrows, the blue arrows pointing outward, and that will give us vasodilation and increased vascular permeability. So you need to know these products. These are the products of the both pathways. Lypooxygenases will give us either chemokines and bronchospasm, where there will be vasoconstriction. You see these arrows pointing inward. That means the blood vessel will get tighter, and you see the spasm, and we will have increased vascular permeability. While 12 lipoxygenase will give us the lipoxins, and that leads to the inhibition of the inflammation. However, the cyclooxygenase will give us one of three products. That's prostacyclin, PGI2, which is involved in vasodilation and inhibition of platelet aggregation. We will have also thromboxane A2, which causes vasoconstriction and platelet aggregation. And we will have also, as a third product, the PGD2s and the PGE2s. And these are types of prostaglandins that cause vasodilation and increased vascular permeability. I also want to talk about there are drugs that inhibit these cyclooxygenases, such as the aspirin and the celecoxib. And what they do, these aspirins, they irreversibly block the cyclooxygenase 1 and 2. And when cyclooxygenase 1 and 2 are blocked, that means there will be no synthesis of all of these prostaglandins that participate. So there will be no vasodilation, there will be no platelet aggregation, there will be no vasodilation and increased vascular permeability. So there will only be, you see, there's COX-1 and COX-2. COX-1 has been shown to be responsible for this pro-inflammatory action, and also is responsible for physiological prostaglandins. So prostaglandins are not entirely exclusive participant in the inflammation or inflammatory process. In fact, as we talked in some other videos, we talked about how the gastric mucosa can be damaged severely in people who use aspirins, which is or these other NSAIDs. These NSAIDs, non-steroidal anti-inflammatory drugs. These NSAIDs inhibit, like I said, cyclooxygenase, preventing the synthesis of prostaglandins. Prostaglandins are key, crucial, required precursors in the synthesis of the gastric mucosa. So for people who use these NSAIDs and block the cyclooxygenase, in order to rid themselves of the pain that comes with inflammation. There's a side effect where prostaglandins are very important in the synthesis of that mucosal layer that protects the gastric, that protects the stomach from ulceration. So that is a big problem, because you have this prostaglandin that participates in the inflammation, but it also, so that's a pathological thing, where we have the prostaglandins participating in the inflammation, and we have prostaglandins participating in physiologically. We have pathological involvement of prostaglandins in inflammation, and we have physiological involvement of prostaglandins in the synthesis of the gastric mucosa. So when you block the synthesis of prostaglandins, yes, you do get rid of that pro-inflammatory pain, but you also damage that gastric mucosa because you're not building it due to the inability to synthesize these prostaglandins. So now they started to examine carefully COX-1 and COX-2. They realized that it was cyclooxygenase 1, COX-1, that was pivotal and crucial for the physiological function of the prostaglandins. So now they started targeting COX-2, until they also discovered that cyclooxygenase 2, maybe it is not involved in the building of the gastric mucosa, but they realized that in COX-2, you will have, COX-2 is involved in thromboxane generation. And you know thromboxane generation is important for platelet aggregation and vasoconstriction. So if you block COX-2, what happens is you will have prostacyclins that are active, while thromboxane, you will have, you will have prostacyclin inactive while thromboxane being active. And that leads to the clotting of the blood vessels. So now what happens is, like I said, prostacyclin and thromboxane, they are against each other. Prostacyclin and thromboxane are against each other. And what happens is, if we block this, the synthesis of prostacyclin, that means thromboxane will be active, and we will have this clogging and the generation of platelets that aggregate in the core of the blood vessels, and this is implicated in coronary heart disease. So I would like to apologize for a mistake that I made in the beginning, where I said in the cyclooxygenase pathway there is no anti-inflammatory events, and that is not true, because as you see here, thromboxane is not really pro-inflammatory. It's only the prostacyclins and the PGD2s and PGE2s that are associated with pro-inflammatory vascular events, where we will have vasodilation and increased vascular permeability, and with the PGD2s and PGE2s and prostacyclin, we will also see vasodilation. But it is the thromboxane A2 that is associated with vasoconstriction and the aggregation of platelets. So it's a balance. It's a balance. You need to know that. Please review this, and if you have any questions, drop it in the comment section. Thank you very much, and see you in our next discussion.